Hey guys, today we're going to do section 5 on curve sketching. You may want to have a piece of notebook paper handy, and I have already filled in some of your information for you. So this is a little chart that may help you figure out what your graph is supposed to look like. If f prime is greater than 0, that means it's increasing. And if f prime of x is less than 0, you are decreasing. If f double prime is greater than 0, your graph is concave up. If f double prime is less than 0, you are concave down. This is what increasing concave up looks like. This is what decreasing concave down looks like. Increasing concave down and decreasing concave down. So concave up, increasing, decreasing concave up, increasing concave down, and decreasing concave down. I've already filled in example number 2 for you. So what I want you to do is pause your video, get your notes copied down. And as you copy down your information, I want you to kind of process what it is you have looked at, what you were given, what you used to create your graph and to create your charts. So the values that are given in parts 1 and 2, -1 and 3, -3, -1 and 3, those are what go in your charts. So for G prime, you have -1 and +3. And it tells you that you're greater than 0 from -infinity to -1 and from 3 to infinity, and you are less than 0 from -1 to 3. So that means you create a maximum and a minimum. For G double prime, it is greater than 0 from -infinity to -3. It is greater than 0 from -1 to 3. It is less than 0 from -3 to -1. And it is less than 0 from 3 to infinity. And your limits as x approaches infinity are going to be 4 and -4. So as x approaches negative infinity, your graph approaches -4. And as x approaches infinity, your graph approaches 4. Those let you know that you have horizontal asymptotes. So again, make sure that you get your information down. You are increasing till you hit -1. You have a max. You are decreasing, excuse me, till you get to 3. You have a minimum. And then you are increasing again. You have a point of inflection at -3, so we're going from concave up to concave down. And then at -1 and -3, you don't have points of inflection because those are at extrema, maximums or minimums. The information that you see here is very, very important, so take just a minute and look over that. It is something from the last chapter. Take just a minute and pause your video and look. All right, and now we're going to take a look at example number 3. Discovering key concepts of analyzing the graph of f prime. So notice you are given the graph of f prime, and we're going to have a sign chart for f prime and f double prime. So zeros of f prime, that means your x-intercepts of f prime, interpret that to f, so backing up from f prime to f, these may be extrema, max or min, going from positive to negative and negative to positive. So extrema on f prime, like here, are possible slope is 0 inflection points. When f prime is above the x-axis, f of x is increasing. Below the x-axis means you're decreasing. If f prime is increasing, then f double prime is greater than 0. So f is concave up. And if f prime is decreasing, f double prime is less than 0. So f is concave down. All right, so looking at f prime. So we're going to call this point A and point B. So from negative infinity to point A, our graph is above the x-axis. From A to B, it is below the x-axis, and from B to infinity, it is above the x-axis. So to fill in the F prime chart based on the graph that you see here, you have to know, is it above or below the x-axis? And then for F double prime, you're looking for the slope of F prime to determine your signs. So we know that 0 is going to be our point on F prime for our horizontal at our horizontal asymptote at our extrema. So we are decreasing till we hit 0, and then we are increasing once we hit 0. So we're going to, let's look at max and min. So we go from positive to negative. So we have a max at A, and we go from negative to positive. So we have a minimum at B. So we have a maximum at A and a minimum at B. And we have a point of inflection, which will be in the middle of those. So our slope, we are going to hit our max, and then we are going to hit our min, and then we are going to continue on our graph. So our point of inflection would and should be around 0. I have given you some hints here. I would like for you to copy those down. I'm going to pause the video, copy those down, get yourself some answers, and we will come back in just a couple of minutes and check. Hope you guys have had a chance to look at example number 4. Here are the values that you should have found. All right, for part A1, you should have gotten the interval from -5 to -2 and 4 to 6. This is where you have a positive slope and it opens up. Part 2, both decreasing and concave down on -1, 2, because you have a negative slope opening down, and your concavity changes occur at x equals -2, 2, and 6. Part B, on what open interval is f of x decreasing? You're looking for below the x-axis. F decreases on 2, 6, where f prime is less than 0. At what x value does f have a local max and justify? Remember, justify means you've got to tell why it's happening. So at x equals 2, f has a local max because f prime of x changes sign from positive to negative. And number 3, on what open interval is it concave down? F is concave down, where it has a negative slope, where f prime decreases, which is on -8, -5, and -1, 4. And part 4, at what x value does f have an inflection point? That means you're looking for x values of max and min at x equals -5, -1, and 4, because f double prime is 0 and f double prime changes sign from negative to positive or positive to negative. And then part C, on what open interval is f concave down? That means below the x-axis. Where f double prime is less than 0, f of x is concave down on 2, 6. And for part 2, we're looking for the x-intercepts of f double prime. This is where you have an inflection point at x equals 2 and 6, where f double prime is 0 and f double prime changes sign from positive to negative or from negative to positive. Again, pause your video if you need to make some notes. All right, looking at example number 4, part D, a couple of things we need to make some notes on here so that we can figure out how best to do our graph or create our graph. So this is the graph of f of x. On the same set of axes, sketch and label a possible graph of f prime in red. All right, so we'll get to that here in just a minute. So what's happening is we're going to do kind of a graphical analysis of f of x to see what it would look like on f prime. So on our f of x graph, what's happening is from -8 to -5, we are decreasing. And then from once we hit -5, -5 is a minimum. And then from -5 to -1, our graph is increasing. And then we hit a maximum. Then from -1 to 4, we are decreasing. And at 4, we have a minimum. And then from 4 to 8, we are increasing. And that will be at the end of our graph. So what we need to do now is see, excuse me, if this is f of x, what does the graph of f prime look like based on that information? All right, so looking at decreasing, that means on f prime, we will be below the x-axis. The minimum point will be an x-intercept. Increasing will be above the x-axis. Maximum will be an x-intercept. Decreasing will be below the x-axis. Minimum will be an x-intercept. And then we will be above the x-axis. So I want you to take a look at that and see if you can figure out what your graph should look like based on that information. Take just a second. And let's put that on our graph in red. Easiest thing to do is start with our x-intercepts, -5, -1, 4, and that's it. So those are going to be our x-intercepts. So we're below the x-axis from -8 to -5, and then we are going to be above the x-axis from -5 to 1. So between -8 and -1, we need to be above the x-axis. So from from -8 to -5, we are below. From -5 to -1, we are above, but we are increasing and then decreasing. So it should look something like this. And it doesn't give us a point to start. So we're going to go up. We're going to continue to increase. We're going to hit that high point, which appears to be a kind of a sharp point. And we're going to decrease. And then at 2, because we hit a maximum, at 2 from positive to negative, we hit a minimum here. We're going to go up to 4. Here's another x-intercept from decreasing to increasing. And then we're going to end up at 8. So there is a little bit of an analysis there to help us draw our graph. Now, will they all look exactly the same? They will not. That's just the one that we created there. So what's going to change here for part E is this time, instead of being given F, we're given F prime. And we have to work backwards to get F. So our notes are going to look just a little bit differently here. And then we're going to create a graph of F of X once we're finished with that. Okay, so for F prime, here's what we have on our graph. From f prime, we are above the x-axis from -8 to +2. And then from 2 to 6, we are below the x-axis. And from 6 to 8, we are above the x-axis. We have extrema, that means max or min, at x equals -5, -1, and +4. -5, -1, and +4. And we have x-intercepts at x equals 2 and 6. And we're not including here, even though we have an x-intercept, because we've already included it in our extrema. Excuse me. Pay close attention to what you're doing here, because you're going to be doing one on your own just like this here soon. So what does this look like on the graph of f of x? So -8, 2 from on the interval from -8 to 2 is above the x-axis. That means the slope is negative, the graph is decreasing. From 2 to 6, you are below the x-axis. I'm sorry, I did those backwards. This is increasing. I was looking at the wrong thing. I was looking at the next one. So above the x-axis, slope is positive, graph is increasing. Below the x-axis means slope is negative, we are decreasing. Above the x-axis, slope is positive, increasing. The extrema will mean point of inflection on f of x. And the x-intercepts, x equals 2 and x equals 6. At 2, you are going from increasing, positive, to decreasing, negative. So increasing to decreasing is a max. And at 6, you are going from negative to positive, negative to positive, so you have a minimum. Now, you want to go ahead and plot these points on your graph and then take into account where your graph is increasing or decreasing. So at 2, you have a max. And at 6, you have a minimum. We'll just draw it here. The point -8, -2 is on the graph. And you are increasing until you hit +2. So you are increasing until you hit +2. You know at -5, you have a point of inflection. You know at -1, you have a point of inflection. And you know at 4, you have a point of inflection. So going from a maximum to a minimum, that makes sense. From a maximum to a minimum. So you have a point of inflection here. And if that's a minimum, that means it's just going to keep on going to end your graph. So sometimes doing your graph kind of out of order is okay. So if this is a point of inflection here, then our graph may be going from concave down to concave up. Now notice at -2, you have a point of inflection on your graph of f prime. So that is going to create kind of a weird space here where we go concave up. We have a point of inflection at 1. And remember, we're continuing to increase. So if this is concave up, we're going to concave down, and then we're going to hit our maximum. Just kind of a weird graph there. And again, that's not the only one that you can have. As always, let me know where your questions are. We will take care of those during our face-to-face time or on Zoom. All right, we are going to look at guidelines for analyzing the graph of a function. I have filled in just a couple of things here again to save some time. So when you analyze a function, you're looking for some specific things. Determine the domain, intercepts, asymptote, symmetry, find critical points and intervals where you're increasing and decreasing, determine local max and min, determine concavity, points of inflection, and then sketch the curve. All right, so we're going to do all of those things here for example 5, but I'm also going to have you grab a piece of notebook paper because I want to show you something that may help you create that graph a little bit easier. So as we look at our graph, go ahead and find your notebook paper. And we're going to start with our function. G of x equals x plus 2 times x minus 1 squared. And from this g of x, we should be able to go ahead and find our x-intercepts and our y-intercepts. Because remember, we're creating this graph without a calculator. So we need to be able to analyze this function to be able to create this graph. What I'm doing here for number 5 for you guys, if this is a method that you like as opposed to the method that you see in the notes, feel free to do so. It may take you a couple of extra minutes, but if it helps you get the problem right, that's what you're going for. So your x-intercepts occur where y is equal to 0, and your y-intercepts occur where x is equal to 0. So the y-intercepts are the easiest to find. And your x-intercepts are going to be where y is equal to 0. So what makes y equal to 0 is plugging in your values. So for this one, it's already factored for us, so they're both pretty simple. So in order for y to equal 0, the x-intercepts come from the functions that you see here. So what makes this 0 and what makes this 0 is negative 2, 0 and 1, 0. Now, if this were not factored, it would be a lot more difficult. So when x is 0, 2 times negative 1 squared, 2 times 1 is 2. So on our graph, in just a couple minutes, those will be some pieces that we will plot. Now, for sake of time, I have done my polynomial multiplication, and g of x equals x cubed minus 3x squared plus 2. And I want to do that so that when I find g prime and g double prime, it makes things much easier. So g prime of x is going to be 3x squared minus 3, set that equal to 0, and x equals plus or minus 1 are my critical numbers. Those are going to be part of my chart here in just a minute. So I'm going to put a little star there. And then I'm going to find g double prime, which is 6x. I'm going to set that equal to 0. And x equals 0 is what I'm going to call my possible point of inflection. Also part of my chart. Now, this chart that you're going to see is new, but it's extremely, extremely easy to fill in. And it's extremely easy to graph from it. And that's our goal. So it's going to take us just a minute to fill this in. So we're going to have our intervals, f of x, f prime of x, f double prime of x, and characteristic. We're also going to have test values over here in this column. So we're just going to draw our lines. I'm not sure exactly how many we'll need, so if we need to extend it, we can. And our intervals are going to include our critical numbers and our possible points of inflection. So the way we're going to set that up is find the lowest, which is -1. We're going to go from negative infinity to -1, and then x equals -1. and then -1 to 0, and x equals 0, and 0 to 1, and x equals 1, and then 1 to infinity. Well, look at that. Didn't mean to do that, but that was perfect. Test values are simply values in that interval. So -2, -1/2, 1/2, and 2. And notice you don't need test values because those are exact values. Now, when you go to fill in your chart, you don't need anything for f of x for the intervals. So you can just kind of blot those out. Keep in mind you should be doing this without a calculator. And these are all g of x, and I put f, and I'm sorry. So if you want to put g, if that makes you feel better, you can. All right, so the function here that I'm plugging in is x cubed minus 3x plus 2 for f prime or g prime is 3 times x squared minus 1. F double prime is 6x, just to make it easier. So when I plug -1 in here, I get -1 plus 3 plus 2. So that should be 4. Plug in 0 and you get 2. Plug in 1. 1 minus 3 plus 2 is 0. Now, you need exact values in column 1. Write it down if you need to, exact values. You need signs for 0 here. Say positive, negative, or 0. All right, f prime. Plug in your test value, -2, and I just need positive or negative. So 3 times -2 squared, 4 minus 1, positive, positive times positive is positive. Plug in -1, -1 squared gives me 0. Plug in -1/2, that's positive times negative. Plug in 0, negative. Plug in 1/2, negative. Plug in 1, 0, and plug in 2, positive. Same thing for 6x. A little bit easier here. Negative, 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 0, positive, positive, and positive. So to figure out your characteristic, it's pretty simple. Are you increasing or decreasing? Concave up or concave down? Increasing, concave down. If f prime is 0 and f double prime is negative, remember it's the opposite of what you think. This is a maximum. Negative, negative is decreasing. Concave down. Remember that chart at the very beginning when I showed you what these look like. If f prime is negative and f double prime is 0, this is a point of inflection, which you should see when we do our characteristic here. This is decreasing, concave up. Notice the change in concavity. 0 and positive is a minimum, and positive is increasing, concave up. And if you're creating this chart, you can think of your own abbreviations to help you do your graph. All right, so we are going to plot our max and our min first. Our maximum is at -1, 4. -1, 4. Our minimum is at 1, 0. And our x-intercepts are at -2, 0 and 1, 0. And our y-intercept is at 0, 2. And 0, 2 is our point of inflection, which we know. And then you just connect your dots. We are increasing, concave down. We hit a maximum. We are decreasing, concave down. We hit a point of inflection. We are decreasing, concave up, hit a minimum, and we are increasing, concave up for our function. So again, if you like that chart, feel free to keep it. If you don't and the other is perfectly fine, then you're welcome to keep that as well. All right, so let's fill in what we know based on what we just found. Our x-intercepts are -2, 0, and 1, 0. Our y-intercept is 0, 2. It's actually g prime, g double prime. This is 3x squared minus 3. We said that was 3 times x squared minus 1 equals 0, and x is plus or minus 1. For our critical numbers, 6x equals 0, so x equals 0. So I'm giving you both in case you want to use one or the other. So we have -1 and 1, and we found that this was positive and negative and positive. So we are increasing from -infinity to -1 and from 1 to infinity. And we are decreasing from -1 to 1. Excuse me. On g double prime, we have 0, and we found that this is negative and positive. So negative and positive. Our relative max, I'm sorry, I'm looking at the wrong one. Positive to negative. So we have a max at x equals -1, and negative to positive, we have a min at x equals 1. If we were to plug those values in, this would be the point -1,4, and this would be the point 1, 0. Now we're ready to look at the sign chart for g double prime. We are concave down from -infinity to 0 and concave up from 0 to infinity. Point of inflection at 0, 2. So even if you chose to kind of do both, to me, that notebook paper really helps you fill this in quickly. All right, now we're going to take a look at graph number 6. Graph number 6 is exactly like graph 4E. So I'd like for you to take just a minute, pause your video, and try to do it on your own, and then come back and we will do it together. So you're going to do f prime of x here, and then f of x here. So I'm going to pause your video, give you guys a chance to work, and then we'll come back and look at what you have. All right, guys, welcome back. Hope you had a chance to get your work done and get your graph right. So on f of x, from -8 to -5, you are below the x-axis. You are above from -5 to -1, below from -1 to 3, and above from 3 to 8. You have extrema at x equals -3 and -1. You have x-intercepts at -5, -1, and 3. And you're going to have a point of inflection at this little corner here, because you can see you're going from concave down, from concave up to concave up. So what that means, below the x-axis on f of x, your slope is negative. You are decreasing. Above, slope is positive, increasing. Below, slope is negative, decreasing. And above, slope is positive, increasing. You have points of inflection on your new graph at -3 and 1. At x equals -5, you are going from negative to positive. That's a minimum. At -1, you're going from positive to negative. That's a maximum. And at 3, you're going from negative to positive, which is a minimum. So taking these characteristics in place, as well as the given point that you have here, plot your points here first. Plot your points here first. Understand that when you connect those, your points of inflection are going to show up. You have your little corner here at 5, and then you are continuing to increase. Taking a look at example number 7, the function f of x is defined and differentiable on the closed interval from -6 to 6. The graph of f prime is shown here. For each question, find the value of y equals f of x on the open interval from -6 to 6 and justify your reason. So find the x-coordinate of each critical point for y equals f of x. So you're looking for the x-intercepts. So -4 and 0. And we're not going to include 6 because 6 is not in the open interval. It would be in the closed interval. Find the x-coordinate of each relative extrema and label it as a maximum or a minimum. So you're looking for below the x-axis and then above the x-axis. You're looking for those changes. So at x equals -4, f prime of x changes from negative to positive. So x equals -4 is a relative min. Now, you're not changing from negative to positive or from positive to negative anywhere else. So that will be your only extrema. Find where it's increasing or decreasing. Increasing is going to be above the x-axis and decreasing is going to be below the x-axis. So f prime of x is greater than 0 means f of x is increasing on -4 to 0 and from 0 to 6. Increasing is above the x-axis. F prime of x is less than 0 means f of x is decreasing. And it is decreasing from -6 to -4. It is below the x-axis. Find the x-coordinate of each point of inflection. For your point of inflection, you are looking at where you're changing signs. So at x equals 4, you're changing your slope signs. And at x equals -2, you are changing your slope signs. So f double prime of x, these would be your tangent lines for f prime, changes sign from positive to negative. And then we have another one because we're changing at x equals 0. F double prime of x changes from, we're going down first and then we're going up. So f double prime at -2 would be 0. F double prime at -2 would be 0. F of -4 is going to be a point, a sharp point, so that will not exist. And then you will have another sharp point at 0, so that will also not exist. So f double prime of 4 and f double prime of 0 do not exist because of your sharp points. You may want to make a note here for these first two. Changing sign from positive to negative means you are changing from increasing to decreasing and then from decreasing to increasing. And then find the intervals over which you are concave up or concave down. Remember, you're looking at the slopes of what you see here because this is f prime. So f double prime of x is greater than 0, meaning f of x is concave up. You're looking for those positive slopes where it's increasing. It is increasing from -6 to -2, and it is increasing from 0 to 4. And then f double prime of x is less than 0, means f of x is concave down. And that occurs from -2 to 0 and from 4 to 6. So again, you may want to make a note. This first one is where you are increasing, and the second one is where you are decreasing. Lot of graphical analysis in this particular section. As always, pause the video at any point to be able to catch up with your notes. All right, let h of x be a function that is continuous on the interval from 0 to 6. The function h is twice differentiable except at x equals 3, where the derivative of h does not exist. The function and its derivative have the properties indicated in the table below, and use the table to sketch the graph. If your function is continuous, but you have a derivative that does not exist, chances are pretty good you're going to have a sharp point or a cusp. So we're going to analyze each h prime, and h double prime, and we're going to start with h of x. At h of x, you are creating points on your graph. Those points are 0, 3, 2, 0, 3, negative 3, and 5, 0. And you can go ahead and put those on your graph. And you know that it doesn't exist at x equals 3. So at x equals 3, you should have a sharp point. All right, so again, there are your points. And we've interpreted that and put that on our graph. Now we're going to look at h prime. On the interval from 0 to 2, it is negative. That means from 0 to 2, your graph is decreasing. First derivative increasing or decreasing. On the interval from, let's see, it looks like 2 to 3, we are still decreasing. On the interval from 3 to 5, we are increasing. And on the interval from 5 to 6, we are increasing. Now we're going to analyze h double prime. That's our concavity. Concave up or concave down. Zero to 2 is negative. So on 0 to 2, you are concave down. On 2 to 3, you are positive, so you are concave up. On 3 to 5, you are negative, so you are concave down. And on 5 to 6, you are positive, so you are concave up. All right, so from 0 to 2, you are decreasing concave down. From 2 to 3, you are decreasing concave up. From 3 to 5, you are increasing concave down. And from 5 to 6, you are increasing concave up. So as you can see, you ended up with that sharp point here based on your concavity and your increasing and decreasing. Example number 9, you have the graph of f prime. It is defined and differentiable on the closed interval from negative 6 to 5. And in the figure below, it has horizontal tangent lines at negative 3 and positive 2. Find the x-coordinate of each relative extrema from negative 6 to 5 and identify it as a maximum or a minimum and justify. All right, we're looking for sign changes. So we're going to have maximums at, maximum is positive to negative. So positive to negative, negative 5 and 4. Because f prime changes from positive to negative. Remember on the graph of f prime, that is above to below. And then we have a minimum. We're changing from below to above at x equals 0. F prime changes from negative to positive and that is below to above. Just some little side notes to make it easier for you when you go to look at your notes. Find the x-coordinate of each point of inflection for y equals f of x. Point of inflection. So we're looking again for a sign change, but this time we're looking for f double prime, and it would change sign from negative to positive at x equals -3, decrease to increase. And it would also change sign from positive to negative at x equals 2, and that's increase to decrease. Increase to decrease. So find g prime of -3. G prime of x is 3x squared minus f prime of x. G prime of x equals 3x squared minus g prime of x, g prime of -3. So g prime of -3 equals 27 minus, all right, g prime of -3 is -6, and that's 33. There's a lot going on in this section. If at any point you need to review the video, feel free to do so. Make some notes with your sticky notes and your different colors, and let me know where I can help you. This will be a big topic for your AP exam, so it's something that you're going to want to make sure you know. Guys, I hope y'all have a great day. This is the end of chapter 5, and we'll be testing soon. Hope you have a great day.